Hello, welcome to Algebra 1. Here we're talking about equations still, that third learning target. Today probably is our last set of notes specifically about solving equations when you only have one variable. Most commonly we write that as x, although that's just not necessary. So we got two small topics here today. The first one is multiplying by a number to remove fractions. If this first topic makes sense to you as we go through it, that's great. It can kind of improve your life and make everything seem simpler. If it doesn't quite make sense to you, it's not actually a terribly big deal. This business about multiplying to remove fractions is really just kind of a shortcut to make it easier for you. So don't get frustrated about not understanding it. You can always just play with the fractions and add and subtract fractions, and which is actually not so hard anymore now that we have pretty good calculators. Okay, too much talking. Let's go. So we have our first example here. We have 2/3 x, we have 5/3, and we have 8/3. Notice that the denominator is 3 for all of them, right? So you can see here that the bottom of the fractions are all 3. Because of that, you're going to want to go ahead and multiply the entire equation by 3. Often it's shown like this, where you put the whole equation in a set of parentheses and write a little times 3 on the side. Some other people show each side of the equation separately, times 3. Doesn't really matter. It's just notation along the way. Anyway, so here, let's go. If you multiply by 3, then the 2/3 turns into 2, and the 5/3 turns into 5, and the 8/3 turns into 8. This is the kind of multiplication that hopefully you do not need a calculator for. There's nothing wrong with using a calculator, but the whole point is to try to make it easier for you. Once you're here, it's actually, pretty fast. You subtract 5 from each side, and then by 5s, so 2x equals 3. Then divide by 2 on each side, so by 2, x equals 3/2. And again, you could instead write it as 1.5 decimal form, or if you insist, 1 and 1/2, which is mixed number form. Let's do another example. Here we have 2/3 x plus 5/6 equals 8/3 times x minus 2. Now, I included this example also because we still have fractions and denominators, although they're not all the same. So notice that some of them are 3, some of the denominators are 3, and one of them is 6. So you need to multiply by a number big enough to remove all of those denominators. So what you're going to need to do is multiply by 6. Now, as a quick reminder, over here on the side, I'm going to write down, remember that 6 is 2 times 3. That will matter in just a moment. As we multiply by 6, the 2/3 is going to turn into 4. So it's 4x, and that's because the 6 is 2 times 3, so kind of the 3 parts cancel out. You add the 2 from before, plus kind of the leftover 2 from the 6. That makes 4. For the 5/6, that just turns into 5, because the 6's kind of cancel each other away. And then on that 8/3, same thing as before with the 2/3, that's going to go ahead and double the 8 to 16. Notice that the stuff inside the parentheses, the x minus 2, does not change. That's a big deal. We multiplied that term by 6, but we just showed all the effect on the outside coefficient, the outside number. Now, you're used to this, so you got a distributive property action, so 4x plus 5 equals 16x minus 32. Then subtract the 16x. That's if you believe in doing letters to the left. It's not mandatory that you do that. You could have moved the 4x instead. I just like to be consistent. This leaves us with negative 12x plus 5 equals negative 32. All right, so now, moving the 5, so negative 12x equals negative 37. Yeah, okay. So you got to divide by negative 12, because, it's negative 12 times x, so divide by negative 12. And then the negative 12s go bye-bye, and so x is positive 37 twelfths. If you prefer decimal, it's 3.083 with a bar on just the 3, and it's also 3 1/12 as a mixed number. Really, you're just better off, in most cases, using the improper fraction. As you can see, the decimal versions get ugly depending on what the denominator of that fraction is. Just really better off using the improper fraction. Okay, that's examples of those, and as I said at the beginning, if multiplying by a number makes sense to you, great, it can save you some time. You'll notice that all the work that we did while solving was with integers, kind of whole numbers. That's nicer than working with the fractions, but if it's causing you stress, then it's not worth it, and you should just go ahead and do the work with the fractions. Okay. This next business is entirely different from the first stuff. I mean, well, we're still solving equations, but it has nothing to do with making life easier. These are situations that do actually pop up. So, here we've got a 4 that needs to be distributed. To remove parentheses, that shouldn't seem very exciting yet. You got 8x minus 20 equals 8x minus 20. That's a little strange. They look similar. Well, let's just kind of power through for fun. If you subtract 8x on each side, then bye-bye, 8x is... and then if you add 20 to each side, then bye-bye 20's 2, so 0 is 0. Well, I guess that's okay with me. Happy face action. No, if 0 is 0, it's the same number. And if you have the same number, it's infinite solutions. And the last thing I want to point out about this problem right here is that you might have very well noticed right way back up here when it was the exact same thing on both sides of the equation. If you see that and you notice it, you can just go ahead and write down infinite solutions there. Or, if it took you a little bit longer to notice and you just happened to notice when you got there, when it wrote negative 20 equals negative 20, you're like, hey, those are the same. You can go ahead and write infinite solutions there as well. You don't necessarily have to solve it all the way out, but really, I did to help you notice, or also to show off my little happy face. Okay, one more example here for you today. This one, wow, we've got some parentheses, so, distributive or double rainbow time. So you got a 6x minus 3 plus 5 equals 6x plus 18. And then still the 7. Yep, okay. Go ahead and, combine the like terms. So you got negative 3 and 5, 18 and 7. So 6x plus 2. And that equals 6x plus 25. That looks similar, but they're not the same this time. So let's keep going. Move the 6x off of the right, moving letters to the left, maybe. And then the 6x's are both gone. So 2 is 25. And you know what? 2 isn't 25. You can try to move the 2, I guess. You get 0 is 23. 0 is 20. Isn't really this. No. No solution. If the variables go away entirely, but the statement is not true, like 0 equals 23, or above it, 2 equals 25, you can say, nope, no solution. Again, like before, you might have noticed it earlier. Most likely, maybe up here at this level, you would say, nope, the variables are going to be the same, which means they will go away together. But the constants are not. The 2 and the 25 are not. No. You obviously might well have noticed it there also. Just like in example 3, if you notice ahead of time what's happening, with confidence, you're pretty sure you're right, then you can go ahead and stop the problem and just go ahead and write the answer. Hey, that's all for today. Thank you very much for watching, and please let me know if you have any questions.